Welcome, SAS family, to Boston University. We're honored to be continuing the annual Space Vision Conference tonight. Thank you all for coming out. We hope you enjoy your stay in Boston, especially if this is your first visit to Boston. We want to start off by thanking the Space Vision Planning Committee and all of the volunteers in Boston University for making this possible, as well as everyone here tonight for helping build Space Vision into what it is today.
Now we'd like to introduce Mike Kelly, who we are honored to be hosting for our opening keynote. Mike's been in the industry for over 30 years, starting out as an engineer at TRW. In the 90s, he formed Kelly Space and Technology, where he worked on developing reusable launch vehicles. Most recently, he now works as a program manager at DARPA's Technical Technology Office. So let's put it together for another groundbreaking Space Vision and welcome Mike Kelly to the stage.
Thank you, Dean, very much for that welcome. I was talking to Dean just outside the hall tonight and asked him how long he'd been interested in space, and he said since he was a little child. So I hope tonight that I can bring back the enthusiasm for space that you've had, because tomorrow my check is coming back to you in the mail. My history, which Dean just summarized briefly, is a little bit of what I'm going to talk about tonight, because all of you are facing careers, your whole life is ahead of you, basically, at least the whole productive part of it. So I want you to take my life as a warning. Have a plan. When I was very young, I actually remember, I don't remember the news of Sputnik, but I remember the word Sputnik. It was one of the first words that I remember. And I do remember the first rocket launch I ever saw. It was the Vanguard 1, which rose an inch or two off the pad and then fell back and blew up. And I remember how shocked my parents were that America couldn't match the Russians. That sort of thing stayed with me. And in May of 1961, or 62 rather, I remember sitting in my second grade classroom and watching Alan Shepard take off on the first American manned space flight. And that was the moment when I knew what I wanted to do with my life. Unfortunately, the years went very quickly. Mercury, Gemini, and Apollo were finished in a flash. And there was a brief follow-on with Skylab, and I was one of what has come to be known as the orphans of Apollo. There was nothing going on in the world of space after the end of the Apollo-Soyuz space Apollo-Soyuz test project, I'm sorry. At least not long term. The shuttle program was moving along, but no one was ever sure if it was going to fly, really. And it didn't have a destination once it got started. So I considered alternative careers, but I pursued my degree in mechanical engineering at Purdue University. When I was about to graduate, the professor I'd been working for, student labor, talked me into staying and getting a master's degree, which was probably the best thing that could have happened. Because by the time I was finished with the research for that master's degree, I gained a lot of experience working in practical things in the laboratory, working with suppliers. I got basically some experience with economics, and also with things that they don't teach in school, like machining and what have you. And by that time, there was a new program that had come along. It was 1980, and the Peacekeeper ICBM was just starting development. I was privileged to get a spot at the TRW Ballistic Missiles Division. TRW was the system engineering contractor for that missile. They were basically the technical oversight function for the Air Force Ballistic Missile Office, and had developed every ICBM since the Atlas. I worked on the fourth stage of the Peacekeeper in the Propulsion and Ordnance Department, became the stage development engineer, and was eventually working on the entire system. And it was the best education I could possibly have gotten. It taught me how a big system is developed, and it also taught me how not to develop certain parts of the big system. It also resulted in my meeting my significant other, Kathleen Hodge, who's sitting in the audience with me tonight. We dated in the 80s, and we're dating again now. I also, after working on the Peacekeeper ICBM, worked for a time on a small intercontinental ballistic missile, which was not a success, but which was instrumental in ending the Cold War. And happened to find that my division manager was a space freak just as I was, and had the same interest in commercializing space that I had when I was younger, but had not found any outlet for. And we started a movement within the company to take the Peacekeeper technology, solid rocket technology, and develop it into a launch capability that would be significantly less expensive and more responsive than anything that had existed before. We undertook that effort for about 5 years, and we're actually getting somewhere within the company, although our main sponsor was Mr. Dan Golden, who was our vice president of the Space and Technology Group. He was called to become the administrator of NASA at one point, and when he left, all of the support for our effort left with him. We had a lot of competition internally for funds, and we were shut down within 5 days. And that's when I left and started Kelly Space and Technology. Actually, it took a year to do it, but I'd taken the contacts that I had made and built up confidence that if I were to come up with the kind of launch vehicle that I was projecting coming up with, and that would be ultimately a reusable launch vehicle that would carry small payloads into orbit, that I would have a significant business base. And that business base was the low Earth orbit telecommunications satellites, the Iridium satellites, later Televisic, and Global Star. These were the bread and butter of the second wave of new space people. The first wave was Gary Hudson, basically. The second wave was Gary Hudson and a bunch of us. The third wave is still Gary Hudson and a few others. I'm unfortunately not in the third wave, but I'll tell you how I'm related to them in just a moment. One of the things that happened with my company was the collapse of the telecommunications market, the LEO telecoms. They had been a dubious proposition from the beginning. And the thing that killed the Iridium program in particular was launch. And it killed it in a way that I'm going to come back to, but I'll tell you what it was now. When we were terminating the contract that Kelly Space had with Iridium, the launch manager, Ted Keel, asked me if I knew why Iridium had died. And I said, yes, I do, but I want to hear it from you. And he said, it was killed by launch. And it was killed by launch because they had built the satellite to be constrained to fly in the Pegasus. It shapes it after a range document, for example. It has a force of law, and they can't change it unless they do a rulemaking. Rulemaking now, for very good reasons, takes a long time. It takes an extremely long time within the FAA. In fact, it takes 5 years once you get the go-ahead to get a rule out the door. So even fixing a bad rule is hard to do. And there are bad rules. We know it. I know it, at least. There are things that we run into all the time that are incompatible with the future of space. So that's the biggest risk. I am on loan, by the way, right now to DARPA, the Defense Advanced Research Projects Agency. I don't know how much you know about DARPA, but it was formed in 1958 by Dwight Eisenhower after the Sputnik 1. And it was formed so that we would never have another surprise like that again technologically. And that's DARPA's mission. It was originally formed as ARPA, the Advanced Projects Research Projects Agency, and then changed to DARPA in 1972, and back to ARPA in 1993, and then back to DARPA in 1996. They're considering shortening again, but it's going to be either DAR or PA, one of the two. The things they came up with are things like the Vela satellites, which were the first satellites to detect nuclear blast by an adversary. The transit program, which was the basis for GPS. Computer time sharing. That was originated with DARPA through General Electric. And of course, their biggest, most well-known achievement is ARPANET, which became the internet. They established all the communication protocols and packet switching, and that's what we use today. It later became commercial. Of late, they've started to concentrate on space launch more and more because it's becoming a problem. We do not have ready access to space. We don't have responsive access to space. We can't get things off the ground quickly. I was brought in by Pam Melroy, who was with the Office of Commercial Space Transportation at FAA for a time. And she brought me in to help with launch. And part of the thing that I'm helping with is appreciation of what the regulations are doing to us and how to deal with those. And there are ways to deal with them, but we have got to start working on it. Another thing I was brought in to do was after the program manager for ALASA left, I was to take his place. Now the program manager for ALASA. DARPA is very good, by the way, at generating acronyms for programs. We have things like MAPFIRES and Exacto, and of course ALASA, which is Air Launch Assist Space Access. And I wanted to make a contribution to that, so when the thing goes operational, we're going to have the ALASA Operations Office, or ALASA OPSO for short. Another thing that is going on in space launch is the XS1 program. This is done by Jess Sponable, who I worked with. He was program manager, he was the contracting officer when I got when I did my TOE flights in Carli Space and Technology. Was with the Air Force at that time. XS1 is an experimental space plane. It's supposed to fly 10 times in 10 days to Mach 10. There are 3 competitors, one of which is a new space guy, Dave Maston, and the program is pressing ahead. There's no guarantee of success in any DARPA program, by the way, and some do fail, but that's the difference between us and other agencies. We take risk. The way DARPA works, by the way, is people come to us with ideas, or we go out to people with ideas and see if we can come to some kind of approach to solving them. And all DARPA does is contract with companies. They do a lot of small business contracting and do it on a very rapid basis, and we manage the contracts. I'm a DARPA program manager. I work with 200 people in the building. We have 1,000 support people, and we're basically program managers, but it is an incredibly creative and fun place. I feel like I'm part of something a little bit bigger at DARPA, and I'm so happy for the opportunity to be there because I've met a lot of smart people. We're seeing something happen there that I think has needed to happen for a long time, and that is we're focusing on what is done in space rather than just how to get there. There's always been the bifurcation. There are programs now, there has been one in the past called Orbital Express, where one spacecraft was used to service another. It was a complete success, but it was rather unheralded and it did not transition well. But it demonstrated what you could do in terms of in-orbit operations on an unplanned basis. There's another program now that is coming along called Phoenix, which is designed to service satellites in geosynchronous orbits, satellites which may have failed for any number of reasons. There's a pretty significant number of failures that happen, many of them right after launch. Some of them we know what happened, many we don't, but Phoenix is based on the proposition that there are a lot of simple fixes that we know can be done to satellites, and to have a servicing capability in geosynchronous orbit could save billions of dollars a year. And that's a big step, and I didn't know about the program until I got to DARPA. It's being run by a colleague of mine, Gordon Ressler. And it inspired me to think back on what I had come up with when I was at Kelly, and never thought I'd get a chance to work on it. I'm not actually working on it. This is just my vision. It's something that I would like to pass along to you as something maybe to motivate you and inspire your vision. As I said, launch constrains us. It constrains what we do in space in any number of ways. And like anything else that you've done for a long time, if you're used to doing it, you deal with all of the overhead. So we deal with the constraints of launch as we have for the last 60 years, and it doesn't seem to bother us much. And when you suggest to people to do it a different way, they resist, even though they can see the advantages. What would happen if you did not assemble satellites and then stick them on top of a rocket and launch them into space? If instead of that, you just ship the parts for the satellites into space on a regular basis, established a big warehouse of parts in space, and as you needed satellites, build them there, build them where they were going to wind up. I've come up with any number of elevator speech ways of expressing this, but I think the best one was if the Air Force wants a satellite, they could call and say, when can you have it in space? Today they get the answer 18 to 36 months once you get it built. If that kind of infrastructure existed, they would get the answer, it's already there, it just hasn't been assembled. And that is powerful. Right now, we can't get assets into space with any certainty in a time frame that we need them. We have rides that, or satellites that need a ride that will never go into space because they can't get one in a timely fashion. If you have the capacity to build these things in orbit and build them on demand, the rate of new satellite creation would go up tremendously, and the constraints of launch would be removed. Today, a satellite is built largely to withstand the first 8 minutes of its life. Those 8 minutes from liftoff until shutdown of the main engine. The vibration environments, the acoustic environments, Gs, all of these things are the biggest stress items on the spacecraft. And after that, it's going to spend 20 years in a quiescent environment and never have to worry about things again. The spacecraft also has to be folded up to fit under a ferry, and then be able to unfold after being abused during launch, and do so deploying its antennae and its solar panels, and do so reliably. A lot of those failures of geosynchronous satellites were due to the inability to deploy either an antenna or a solar panel, either of which could have been fixed easily with a presence on orbit. But if you build something in orbit, you're not constrained by volume, so you can build things bigger. You can build them lighter weight because they don't have to endure the vibration. So your actual feedstock, the launch mass that you put up, the cost of that goes down. You can actually use some subsystems that would be cheaper because they would not be optimized for launch weight necessarily, like tanks. You could build things in a way that they hadn't been built before. And if anybody thinks that that's far out, the existence proof for all of this is the International Space Station, which, if you think about it, could never possibly have been built in its current form as one unit, put on top of a rocket, even if we had a rocket that big, and launched into space. It just wouldn't survive. It could not have been done. You could build satellites today that could not be done, or that could not be done today. Geosynchronous communication satellites with huge apertures, servicing markets that today are not reachable, improving signal quality, having increased bandwidth, smaller spot sizes to address individual customers, that would improve the spectrum usage. The benefits go on and on. Plus, it would have no limit to power levels because solar panels of any size could go up. This sort of thing is actually being absorbed by the community right now. There are a number of companies out there independently thinking about things like this on various scales. And I've been talking to many of them and giving them a little bit of a boost in terms of what I think the vision could be. And I've been surprised at the reception. It's been very, very good. But this could actually be the future of space for you guys, because I think ultimately a facility like this, it would not be an automated facility completely. automation is actually quite good, and it's much better than I realized. The robotic assembly things in space is advancing by leaps and bounds, but you can't replace people for some things. And so if you can imagine this infrastructure in low Earth orbit being tended by human beings, and ask yourself, what kind of human beings would they be? Well, they wouldn't be PhDs, they wouldn't be highly trained athletic astronauts, they'd be technicians, engineers, the kind of people that live, on your street. And I don't want to say ordinary people, but just people going up and doing a job. And how cool is that? That's one of the things about human spaceflight that I think has always been lacking, and that is people are not interested in NASA human spaceflight because of its exclusivity. It excludes people deliberately. NASA would not fly tourists on the space shuttle, so the Russians did. Right now we have commercial manned spaceflight coming up, and if it's for economic purposes, which it can be, I think that will be a game changer and will open up the floodgates for more such development. I've been thinking about these things for 25 years, and I still think about them. I'm actually not doing any of that stuff. I'm involved in some very interesting technology work that is going to be needed when we actually get serious about high flight rate reusable launch vehicles and how they're going to be maintained and operated. Things that technologically have not had to be addressed before now because there was no demand for such launch vehicles. There will be in the future. And there will be a place for people to go to work in space, and not just astronauts, not researchers, but people doing the creation of new satellites, new space probes, etc. The people I talk with are looking at making cislunar space, as they call it, anywhere from low Earth orbit through lunar orbit and beyond, a boom town. And I think that's going to happen within your lifetime, certainly. I certainly hope it happens within my lifetime because I have plans for it. I'm not actually going to do a technical business, but every boom town needs its infrastructure, and in particular, they need saloons. So I'm going to start the first saloon in cislunar space. And when it becomes a boom town, you can come and visit the Cis Boom Bar. Thank you, everybody. Good night.